So thermodynamics, in a very simple term, is actually a subject talking about the energy. How many different type of energies do we have? The first one is the potential energy, and the other one is called the kinetic energy. And in this is actually kind of two big groups, okay, how people actually start to categorize different type of energy. For the potential energy type, you actually have a lot. First one is actually chemical energy. Every single compound actually carries its own energy, and those energies is actually stored in the form of sound energies, okay, vibrational energies, rotational energies, mechanical energy. For example, if today you have a string, you stretch it, you do the work, so the energy actually go to the string, right? So that elastic properties actually also carry the energy, and those type of energies called mechanical energy. Next one is actually the very famous one, nuclear energy, and then the gravitational energy. For the kinetic energy, the first one people talk about is actually radiant energy. We can feel the energy when the sun shines on Earth, right? The other one is actually the thermal energy. So the form you're most familiar with is the heat. Heat is a form of energy, thermal energy. Next one will be motion energy, the kinetic energy. Okay, when things move, it carries energy too. And the next one will be actually the sun also is a form that can carry energy, and then when the electron move, okay, the electric also carry energy. Okay, so back to the beginning of thermodynamics. These are the four type energies that scientists have access to. You realize actually most of the thermodynamics, they are just talking about how the energies exchange from one form to the other. In other words, thermodynamics is actually a subject that handling the energy exchange in different form between your system and your surrounding. So there are three laws of thermodynamics. So I actually summarize these three laws here. Okay, the first one is actually the energy has to be conserved. The second one is actually the random is nature. The entropy is always increased. And the third law is actually absolute zero is not possible. If you look at these three laws from the very surface, it doesn't mean too much. The important thing is actually you need to learn all these state functions, how they actually correlate with each other, how the energy changes from one form to the other, and then how much they change is the things of our main focus. For the first law, we're going to introduce you a few state functions. U is the internal energy. H is the enthalpy. In the second law, we're going to introduce you the concept of entropy. And then third law introduce you the two different type of free energies. Okay, so those are the state functions that we all need to learn through these three chapters. Besides the state functions, there are also some important parameters that scientists use all the time. For example, CV and CP, the heat capacity of a substance. After we finish all three chapters, we're going to go back to this slide. Then we're going to write down all the important equations that you need to memorize. Okay, so now it's actually more about the story time, okay, how things actually evolve since 1798. This is a soldier, eventually become a general, the Count Rumford. He is actually the first person who bring up the concept that the work and the heat are exchangeable. So we know work and heat, they both are a form of energy. But back to that time, there's actually no concept of energy. The things they know is only about heat and work. And the way he found is actually because he's actually a soldier, right? And then his job is actually trying to clean up this cannon. So the way he actually clean up the cannon is actually you use actually a pole, you put it in, and you use holes to do these rotational motions to clean up the inside of the cannon. One day he actually sit on the cannons and then he just watch his horse running around. And suddenly he feel like my butt feel really hot. Then he has a hypothesis that maybe it's because the horse is actually doing the work, and then the work eventually become heat. Okay, and that's why I feel warm. This very simple concept is a brand new concept back to 1798. He actually documented this finding. Of course, that doesn't mean too much because just bringing up the concept, it did not actually provide experimental evidence. So it takes about 150 years that James Joule, okay, one of the most famous scientists for thermodynamics, he actually did a lot of experiments to prove his concept.